In ancient Greece, around 500 BC, Democritus was one of the first people to come up with the idea that all matter, that is, anything that has weight and takes up space, is made of lots of little particles. Democritus thought you could find a particle by cutting up an apple until you found the smallest piece possible. Here it would be impossible to cut the apple any further. The problem was, in ancient Greece, they didn't have great tools for cutting small things. In a museum, you can see examples of the knives they had in ancient Greece. Not very great. Today, we have much more advanced tools. Maybe with these new tools, now it's possible to cut something up until you find a single particle. Today, you're going to try to accomplish this. You will see if you can cut something up until you get a single particle. Now, apples are messy and hard to cut cleanly, so we'll be using something simpler. You're going to be using a strip of paper, kind of like this. Now, mathematicians have calculated that all you need to do is cut a normal-sized piece of paper in half exactly 31 times to get to the size of an individual particle. It'll look something like this. You'll split the paper in half and cut it once. Then split it in half again and cut again. You will keep going for 3 cuts, 4 cuts, all the way until you've cut the paper 31 times. I'm going to walk you through this step by step. Start by gathering your materials. Each person will need these. Next, we want to prepare our paper by making it into a thin strip. A strip will be easier to cut than a full piece of paper. To get started, fold your paper in half long ways. Crease it, then unfold. Next, fold the bottom edge to the middle crease and then unfold again. Do the same with the top. If you've done this correctly, you should have 4 strips of paper. Now it's your turn. Fold the paper just like I did. When you're finished, click Continue. Now we're going to cut out the strip of paper that we will actually use. Cut along one of the creases in your paper. It's okay if it isn't exactly perfect at this step. Keep the one strip of paper that you've cut and put the rest of the paper aside. Your turn. When you're finished, click Continue. Now it's time to make your first cut. Fold the paper in half, like this. Then cut along the crease that you've made. Now it's your turn. Click Continue when you're ready. Now we want some way to keep track of the cuts that we've made. On your lab worksheet, you will start at cut 1 and circle yes because you were able to cut the paper. Next, we want to measure the size of our strip of paper. Line it up in the box and put a mark on each side. Then use your ruler to connect those 2 marks. This line you've drawn, that's the size of your strip of paper. Now it's your turn. Click Continue when you're ready. Now before we keep cutting, I want to point something out. To do this properly, all of our 31 cuts need to be in the same direction. Like in this animation, I cut it in half, and my next cut is moving in the same direction. I'm not rotating or turning the paper. Each time, I'm cutting in the same direction, and my paper never turns or rotates. Now we can repeat the process for cut 2. Fold the paper in half, and then cut along the crease. Go back to your lab worksheet and circle yes for cut 2. Then measure the paper strip in the box on your worksheet. Complete this step. Click Continue when you're ready. Now that you have the pattern down, it's up to you to get to 31 cuts. Each time you cut the paper in half, circle yes on your worksheet. Then measure your paper strip before moving on to the next cut. If you get to a point where you cannot cut the paper in half anymore, circle no on your worksheet, and then click Continue on the screen. Before you start, here are 3 helpful tips. Number 1, remember to always cut the paper in the same direction. Never rotate or turn your strip of paper. 2, it's okay if you don't fold the paper to find exactly half as the paper gets smaller. Just eyeball your cuts and do your best to cut it in half each time. 3, be careful not to cut yourself as the paper gets smaller. We're trying to cut the paper strip and not our fingers. Alrighty. Time to start cutting. Have fun. We'll keep going once everyone has finished. Here's what happened when we tried. The 4th cut was no problem. And the 5th wasn't half bad either. However, when we got to 6 cuts, we started to have some trouble. We were able to get it done though. Cut 7 was hard. The paper was getting really thin. And by the time we get to cut 8, it was almost impossible. Watch as I drop it and have to try several times before I can finally cut the paper in half. I eventually got it and ended up with a tiny strip of paper. That was so small though that I decided to stop. I could not cut it a 9th time. Now it's time to share. How many cuts were you able to make? Let's discuss. Why did it become harder to cut the paper? How much smaller was the paper on your last cut than when you started? It was so important that we measured the paper each cut because it really allows us to explore how small things are getting. Remember that our paper strips started being the size of a normal piece of paper. Even after cutting it the first time, it was still pretty large. But look, in just 8 cuts, the paper turned into a tiny little speck that you could barely see. And 8 cuts is nowhere near what we needed to do to find the size of a particle. If 8 cuts turned a full piece of paper into a tiny speck, imagine how small things would be after 31 cuts. There's no way to cut something into a single particle. And even if we could, there's no way that we'd ever be able to see it. To get around this problem, we use something called models. Models are pictures, drawings, or objects that represent the idea we're talking about. Here, particles. For example, when we talk about the particles in a strip of paper, we might draw a model that looks something like this. Even though we know the particles are way smaller than this in real life, drawing them in this model allows us to talk and learn about them more easily. You will have more chances to work with models later, They're really our only way of talking about particles, because what you've learned from today's lab is that the particles that make up matter are too small to ever see.